Okay, class, this is the Chapter 4 review, and I'd like to take a look at this and try to explain some of the notes that you've seen already in the ed puzzles and how it works out and like what you can do to make it easier for yourself. So let's first take a look at what this says. It says check all the boxes which describe the element. So the elements are on the side here. We got the SBR or SB, SR, RN, and all the way down through. So the first classification is it a metal, metalloid, or non-metal? So let's take a look at our periodic table. Our periodic table here has one clear mark that goes something like this, and to the left, whoa, hang in there. To the left of this, there we go. To the left are the metals. To the right are the non-metals. And those that are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, and not astatine. Those are the metalloids. Okay, so there we have the list of metals, non-metals, and the metalloids. Okay, so we're going to go back and answer these questions, but first, let's see what else we have. We have the alkali, that should actually be the alkali metals, or the alkaline earth metals, the transition metals, the halogens, and the noble gases. So that's our next. So let's go back to our periodic table. So at our periodic table, we have the alkali metals as the first one. Now, the only one that is not an alkali metal here would be hydrogen. So that would be lithium down to francium, are alkali metals. Okay, all the way down. And then here we have the alkaline earth metals, that would be group 2. All the way over on the, and then we have the transition metals here. Transition metals in the middle, they go from scandium all the way over to zinc and all the way down. And then I have halogens. I'm going to move this one out of the way. Then I have halogens here, group 7, and noble gases at group 8. Okay, so those are the classifications for those four. And the last one says monatomic or diatomic. And I'm going to highlight those that are, there we go. I'm going to highlight the ones that are diatomic, okay, and I'll show you what that looks like then. So we got these like that. They're the ones that are diatomic. Okay, so I'm going to put a little smudge up here, and then I'm going to write diatomic elements. Okay, that's an M there, and then that's an I. Okay, diatomic elements are the ones that are highlighted. So that should be able to tell us everything we need to know. Let's head back to the next part here. It says SB. Let's find SB. Let's find out if it's a metal, metalloid, or non-metal. We do this. SB is this one right here. Okay, antimony is number 51. It is marked as a metalloid. Notice it is not a halogen. It's not a noble gas. It's not a transition metal. It's not an alkaline metal, and it's not highlighted. So when we go back to this here, so our first one, SB, is none of these, and it's monatomic, which is why we put that there. So it's a metalloid, it's not any of those groups in the middle, and it's monatomic. So let's take a look at strontium. So strontium is SR, that's strontium right here. So strontium is an alkaline earth metal. It's a metal, because it's on the left-hand side of the red stair-step line. It's not a transition metal, and it's not diatomic, so it's monatomic. Come on, go back, there we go. So that means that it's a metal, it's alkaline earth metal, and it's also monatomic. Okay, let's take a look at radon. Rn is right here. That means it's a noble gas, it's a non-metal, and it's not diatomic. So that's monatomic again. So I go back here. It is a non-metal. It is a noble gas. and it's not diatomic, which means it's monatomic. Okay, do you see how that works? I'd like you to go through each one of these, pick the category that they belong to. They will all belong in some category. Now let's take a look. The next one says, so we got these here. It says physical properties. Well, if it's a metal, okay, so the state at STP, we got the name, state. Is it brittle? Is it malleable or ductile? Is it a good or a bad conductor? So this is basically, we're talking about if it's a solid, solid, liquid, or gas at STP. But if it's brittle, that means we're talking about a non-metal. If it's malleable, that means we're talking about a metal property. If it's a good conductor, is metal. If it's a poor conductor, it's a non-metal. Ionization energy is high or low depending on where it is on the periodic table. So electronegativity is high or low depending on where it is on the table. And whether it loses electrons would be metal, and whether it gains electrons would be non-metal. Okay, so those are the things that we can do to go through that. So carbon here, so I write down carbon's name, C-A-R-B-O-N. That's a solid at room temperature. You can tell that by looking at table S. Okay, and that would be the whole like melting point. If the melting point is lower than, if it's lower than 298, then it would be a solid. Is it brittle? Yes, it's brittle because carbon is a non-metal. So that means it's not malleable, it's not ductile, it's a poor conductor because it's a non-metal. Its ionization energy is high because it's on the right-hand side of the periodic table, not the left-hand side. Its electronegativity is also high because it's on the right-hand side, not the left-hand side, and it gains electrons, not loses electrons. Okay, although it can do both. So let's do another one. You can see what I did for silver here. Let's do magnesium. So this is magnesium. Magnesium is a solid. If you take a look at the melting point, the melting point has to be a lot higher than 278 or 273 or 298. Is it brittle? Well, magnesium is on the left-hand side. It is, here I'll show you. Let's go back. Magnesium is right here, which means it's a metal. So when I go forward again, that means that it's this one, it's ductile, it's a good conductor, it has a low ionization energy, it has low electronegativity, and it loses electrons. Okay, and that's how you do that. You go through, so, and I mark the ones that are, so if it's high electronegativity, that means it's a non-metal. If it's low, it's a metal. If it's ionization energy and it's high, that would be a non-metal. And if it's low, it's a metal. So you can go through and just by knowing whether it's a metal or a non-metal, you can click which property that it belongs to. The only ones here that would not be, the only ones that are a liquid would be bromine and mercury, and the ones that are gases would be on the right-hand side and hydrogen. That's all you have to really worry about. So good luck. I'm sure you guys can figure it out.